A note for the teachers. To make the curriculum learner centered, students should be made to participate and interact in the learning process directly. Once a week or one out of every 6 classes would be a good pre, periodically periodicity for such seminars and mutual interactions. Some suggestions for making the discussion participatory are given below. With reference to some specific topic in this book, students may be divided into groups of 5 to 6. The membership of these groups may be rotated during the year if felt necessary. The topic for discussion can be presented on board or on slips of paper. Students should be asked to write their reactions or answers to questions, whichever is asked, on the given sheets. They should then discuss in their groups and modification or comments in those sheets. These should be discussed either in the same or in different class. The sheets may also be evaluated. We suggest here 3 possible topics from the book. The first 2 topics suggested fact are in fact very general and refer to the development of science over the past 4 centuries or more. Students and researchers may think of more such topics for each seminar. Ideas that change civilization. Suppose human beings are becoming extinct. A message has to be left for future generations or alien visitors. Eminent physics R.P. Feynman wanted to the following message left for future brings, if any. Matter is made of atoms. A lady student and teacher of literature wanted to the following message left. Water existed so human beings could happen. Another person thought it should be idea of wheel for motion. Write down what message which one of you would like to leave for future generations. Then discuss it in your group and add or modify. If you want to change your mind, give it to your teacher and join in any discussion that follows. Reductionism. Kinetic theory of gases relates the big to the small, the macro to the micro. A gas as a system is related to its components, the molecule. This way of describing a system as a result of the properties of its components is usually called reductionism. It explains the behavior of the group by the simpler and predictable behavior of individuals. Macroscopic observations and microscopic properties have mutual interdependence in this approach. In this method useful. This way of understanding has its limitations outside physics and chemistry. Maybe even these subjects. A painting cannot be discussed as a collection of properties of chemicals used in making the canvas and the painting. What emerges is more than the sum of its components. Question. Can you think of other areas where such an approach is used? Describe briefly a system which is fully describable in terms of its components. Describe one which is not. Discuss with other members of group and write your views. Give it to your teacher and join in any discussion that may follow. Third point, molecular approach to heat. Describe what you think will happen in the following case. An enclosure is separated by a porous wall into 2 parts. One is filled with nitrogen gas N2 and the other with CO2. Gases will diffuse from one side to another. Question number 1. Will both gases diffuse to the same extent? If not, which will diffuse more? Give reasons. Second question. Question number 2. Will the pressure and temperature be unchanged? If not, what will be the change in both? Give reason. Write down your answer, discuss the group and modify them or add comments. Give to the teacher and join in the discussion. Students and teachers will find that such seminars and discussions lead to tremendous understanding not only of physics but also of science and social sciences. They also bring in some maturity among students. Units and measurements. Measurements of any physical quantity involves comparison with a certain basic arbitrary chosen internationally accepted reference standard called unit. The result of a measurement of a physical quantity is expressed by a number of numerical measure accompanied by a unit. Although the number of physical quantities appear to be a very large, we need only a limited number of units expressing all physical quantities since they are interrelated with one another. The units of the fundamental or base quantities are called fundamental or base units. The units of all other physical quantities can be expressed as combination of the base unit. Such obtained for the derived quantities are called derived units. A complete set of the units, both the base units and derived unit, is known as the system of units, the international system of units. In earlier time, the scientists of different countries were using different systems of units for measurement.